Okay, we're going to look at section 5.6 for this one. And this one tags on the back of 5.5. Okay, so in 5.5 we were doing integration with substitution, but we were doing indefinite integrals. Okay, so we didn't have any boundings on our integration or anything like that. Now we're going to look at doing integrals with substitution with definite integrals, so we have boundings. Okay, so the idea here is, okay, if we have the integral from A to B, okay, okay, basically what this is saying is if you're going to do this U substitution, you need to change the bounds of your integration. Okay, so when we see one of these, when we do this first example, you'll see what I mean when we do this. Okay, so let's take a look. Okay, so here's our problem that we're going to do. Sorry, a little far there. All right, so we see the 3x squared here. That looks like the derivative of this. So we're going to let u equal x cubed plus 1. So following the stuff we did the other day, du dx will be 3x squared. Sorry, that should be du dx. Du is then 3x squared dx. Okay, now the difference here is, okay, if x is -1, u is then -1 cubed plus 1. So it's going to be -1 plus 1 is 0. If x is 1, and 1 plus 1 is 2. Okay, so now when we do our integration, instead of going from -1 to 1, because that's the boundings for x, we now, because we're going to be in the letter u, we need the boundings for u. So we're going from 0 to 2. Okay, so I've got square root of u, and then our 3x squared dx is du. Okay, so I'm going to switch this out. U to the 1/2. So integrating up, if I add 1, that's going to take me to 3/2. Means I need a 2/3 out here in the front. Du. Okay. Now you've got a couple of options with this. Okay, and this would be evaluated from 0 to 2. You have a couple of options. One is, okay, that you can transfer this all back. Okay, so one option is that you take this back to 2/3 x cubed plus 1 to the 3/2. Now, if you go back to x, you need to go back to x on your boundings. Okay, so -1 and 1 are your x boundings. 0 to 2 are the u boundings. Okay. So now, taking a look, okay, I'm going to do this one, okay, in this purple, and then I'll switch colors and show you what happens with the other one, okay? So I'm going to plug in 1. 1 cubed is going to be 1. So it's going to be 2. So this is 2/3 to the 3/2 minus 2/3. -1 cubed is going to be -1 plus 1 is 0 to the 3/2. Okay, now guys, 0. Square root of 0 is still 0. 0 cubed is still 0. Okay, so this is going to be dealing with this. Now, I've got 2/3 2 to the 3 halves, okay, because that all went to 0. Now, we could cube this, okay? We can cube the 2 and get 8. So I could have 2/3, so it'd be 2 cubed is 8, square root of 8 is 2 square roots of 2. Okay, well, we got done here at the bottom. Now, I have another color here. Looking at it from here, okay, this would have been 2/3 2 to the 3 halves minus 2/3 0 to the 3 halves. Notice, guys, this is the exact same line. Okay, it just required me, I didn't have to plug in the 1 and cube it and the -1 and cube, okay, because you already figured out what the relationship is here. So it allows you, okay, to get to answers a little bit different route, okay, if you want to do the replacements here. It is key and critical, though, that you figure out what those new bounds are, okay? You have to make sure that you are correctly getting your bounding edges changed over when you go over to that new variable, okay? Now then, a couple of other things that happen, okay, or that we need to be aware of. So, and for this, we are all still doing, okay, F is continuous on -a to a, okay? So we're working on a symmetric interval, okay? So we're going the same amount into the negative realm as we are into the positive realm. Okay? So, 2 parts to this. If F is even, okay? So keep in mind that that is the one that will fold in half over the y-axis, okay? Then the integral from -a to a is twice the integral from 0 to a. Okay, so picture sorry, that needs to line up a little better. Okay, the idea here is that since this side is a mirror match to this side, okay, instead of having to integrate across the whole line, we can go from 0 to a and then double it, and that will give us the rest of this over here. Okay, now the other concept, okay, is if F is odd, okay, now keep in mind that's the one that has that origin symmetry where if you put the push pin on the origin, it'll spin 180 degrees and match up, okay? Then the integral from -a to a of f of x dx is 0. Okay, so let's take a look at the picture. So here's a, here's -a. Concept here is this is going to get counteracted with that because we know that it's symmetric. And this gets counteracted with this. So if I'm looking for, remember that when we do integration, it's kind of like displacement, okay? We are taking the amount above the x-axis and the amount below the x-axis. We're not doing total area, okay? Remember that total area uses some absolute value stuff that gets pulled into play for that, okay? So let's take a look. Okay, so now the first thing is I need to decide whether this thing is even or odd. Okay, so I'm going to plug in negative x. Anything to these even powers, the negative is going to get canceled out because it'll have another negative partner. Okay, so that will go back to positive x to the fourth. That's going to go to positive x squared, so that'll stay negative, and that one's not impacted. So this is even. Okay, which means what I can do is I can integrate and do twice from 0 to 2. What this is going to allow me to do is I'm not going to have to worry about plugging in this negative value. Okay, so we've got 2. I'm going to put brackets off here. It's going to be 1/5 x to the 5th minus 4/3 x cubed plus 6x. That's going to be evaluated from 0 to 2. So again, I'm going to do big 2 brackets, okay? I'm going to plug in 2, 4, 8, 2, 4, 8, 16, 32. So that's 32 fifths. Let's see. 2 cubed is going to be 2, 4, 8 times 4 is 32 thirds. Plus 2 times 6 is 12. Then instead of parentheses. Minus, when I plug in 0, I'm going to get 0 minus 0 plus 0. Okay. So now I've got 2 times 32 fifths minus 32 thirds plus 12. Okay. So, okay. So let me move that down. Oh, sorry. A little off screen there. Okay, so I'm going to use a calculator help evaluate. And we end up with either 15.46 repeating or 232 fifteenths. Okay? Kind of whichever way that one would be asked for. Okay? So now, the next thing that we're going to look at, okay, is kind of a extension off of the idea of what integration does, okay? So if we have kind of a curve, and then I've got another curve over here, okay? And we cut, and we go, here's B, and here's A, okay? And then we did our little rectangles thing, okay? In order to get, so let's do, for example, okay, this rectangle right here. In order to find the height of this rectangle, okay, you would have to take this upper function, let's call this one f of x, and let's call the lower one g of x. I would have to take my f of x answer minus the g of x answer, okay, there's x, and then that will get multiplied with our width, right, okay? And again, we're going to make our rectangles really, really narrow, okay, in order to make this happen, okay? So what happens is if I want to find the area between these two curves, okay, what we can do, okay, let me bring this up here, is the area is going to be the integration from A to B of f of x, which is my upper function, minus g of x, which is my lower function, dx. Okay, now The only reason, okay, and this falls, okay, back into the same idea of what we did before. Guys, normally this was f of x, and we were going to the x-axis. The x-axis is 0, okay? So when you integrate 0, you get back 0. So this part didn't exist, okay? So when we were finding area under the curve, all we did was this part. Now, if we want to go between two curves, it's going to look like this, okay? So they ask us to do the area bounded by the curve, y equals 2e to the negative x plus x, on the above. So this is our above. And we have y equals e to the x over 2 below. And then we're going from x equals 0 on the left to x equals 1 on the right. Okay. So let's see what we can hash out with this. Okay, so following our formula from, and we know we go from left to right or from low to high, so 0 to 1 of our upper function minus our lower function, and I'm going to rewrite that as 1/2 e to the x dx. Okay, so now integrating up. Okay, so let's think about this. E to the negative x. The derivative of e to the x is e to the x, but this has a negative, so it's going to pick up a negative. So I need to pick up a negative on the way back up, okay? Because again, the 2 would have been extra. E to the x comes down, but I would have had a negative, so that's going to cancel off. Plus 1/2 x squared minus 1/2 e to the x, okay? Because that's, again, just kind of a constant that's going on there, okay? Okay, and then this is evaluated from 0 to 1, okay? So here we go. Negative 2e to the negative 1 plus 1 squared, it's going to be 1 plus 1/2, so it's going to be 1/2, minus 1/2 e to the first, minus negative 2e to the negative 0 plus 0 minus 1/2 e to the 0. Okay, so I'm going to bring that down and let's evaluate a little bit. So this is going to be negative 2 over e plus 1/2 minus e over 2. We'll bring that back into play. I'll get rid of this parenthesis. Anything to the 0 is 1, so minus a negative 2 is going to turn into plus 2. And anything minus negative is going to be plus 1/2. So about all I'm going to do here is I'm going to combine my half and half to make 1 and then put that with that. So I've got negative 2 over e minus e over 2 plus 3. Okay. If they wanted an exact answer, and then we could certainly, push that down to a decimal if we in fact needed to. Okay. So we have that. So now let's look at another one. Okay. So we have, they want us to do area of the region enclosed by y equals minus x squared and y equals negative x. Okay. Now, the best idea to do this is to go ahead and graph this, kind of even just do just the basic sketch, so on it out, okay? So there's a line y equals negative x, okay? And then this is an upside down parabola that went up to. So here's this, over one, down one. Okay, so there is an intersection point at -1, 1, okay? Here, and then out to down 4. And there's going to be the other one right there. So that's going to be at 2, -2. Okay. So we are now we notice, so we're doing this area right in here. Okay. So we have that the curve is the upper, the line is the lower. So we're going to integrate from -1 to 2 of 2 minus x squared minus a negative x. Okay, so we're going to clean that up here in a bit. I'm actually going to clean it up before we start the integration. Okay, so -1 to 2 of negative x squared plus x plus 2. Okay, just so that it looks a little more traditional in the ordering. Okay, so sending this up, we're going to have -1/3 x cubed plus 1/2 x squared plus 2x, evaluated from -1 to 2. Okay, so plugging some stuff in here. We have got, it's going to be 8, so we've got -8/3. 2 squared is 4 times 1/2 is going to be 2 plus 4 minus -1 cubed is going to be -1 times that is going to be 1/3. It's going to be 1, so it'll turn into 1/2, and then minus 2. Again, I'm going to use calculator here to help evaluate some stuff. So we've got 10/3 coming out of the first part. And -7/6. And that is going to give us 9/2 as our final answer. Okay. Now, sometimes, okay, when they do this, okay, if the functions are defined, okay, so let's talk about our integration stuff when we do this, okay? When we have, so let's go back to our shape that we had here, okay? And let's pull the integral. This was left side, right side, high function, low function, okay? Now, sometimes what's going to happen here, okay, is they are going to define a function in terms of y's instead of x's, okay? So you're going to have some sort of a function that is defined like this, okay? And instead of working with our rectangles going up, they want our rectangles to go across, okay? So the integration for that, thinking the same manner, okay? This was x's from highest. So now what's going to happen is this is going to be low y value to high y value, okay? And then this was the higher or the upper, okay, function over there. So that now needs to be the more positive thing. So this is going to be right minus left, okay? So if you've got to do stuff in terms of y's, okay, first off, all the equations need to be in y's, but we are now going to be working low, kind of the low y value to the high y value, and then we're working from the right minus the left, okay? So let's take a look. I'm kind of slow with this, okay? So we want to do first quadrant. Okay, move up. Let me see. Okay, and we're going to do y equals square root of x, and the line, and either the x-axis or the line y equals x minus 2. Okay, so again, let's get just a drawing going on here. We'll redefine functions here in a minute if we have to, okay? So let's take a look. We've got 1, 1, 4, 2. Okay, so just taking a look, there's that arch right there. Okay. If we do the line, okay, so now there's the line. So they want this region because they said first quadrant, okay? And so the reason they said x-axis was because of this right here, okay? So now, if we think about this, okay, and I'm going to, again, pull a different color here, okay? Our function, now notice, this thing would be kind of a beast to have to do because what I would have to do here is if I was going to do this with rectangles, I would have to break this into two shapes. I'd have to cut it right here where we transition between the x-axis being the lower to the line being the lower. So I'd have to break this up into two integrals, okay? But if I do it in terms of y, I've got one solid continuous shape because my right side is always defined by the line and my left side is always defined by the curve, okay? So now, talking about our curve, okay? We've got that is going to be that. Okay, so here's our two equations. So now we're going to integrate, okay, from, again, we said we need our right side value, sorry, low, y is 0, to the high of y is 2. Right side function is the line, so y plus 2 minus the left side function, which is y squared, dy. Okay, so I'm going to rewrite. Okay, so we've got integral of -1/3 y cubed plus 1/2 y squared plus 2y. Sorry, don't need the integral up here on the front. Evaluated from 0 to 2. Sorry, lost my stuff here. Okay, so that's going to be -8/3 plus 2 plus 4 minus, it's going to be 0 plus 0 plus 0. So again, I'm going to use a calculator here. Okay, and this is going to be 10/3. Okay, so again, instead of having to do this one, okay, in terms of x's and having to split it up into two parts, we can now do it in terms of y, okay, and it creates one solid integration piece that we're allowed to do, okay? That's the end of 5, 6, okay? So hopefully this will be a helpful video.